Hi everyone. So today we're working on 2.2, still in lesson 2. This is on page 24 right here. We're still on such a rad lesson. And here's our do now. Our do now is right here on the right in green. Make a table of g of x with as many points as possible. And so literally if you notice the green points right here, I just kind of wrote them. Notice these ones were all in order. They don't all have to be in order, but those are all the points that we found. And if we notice right here, so how did this basic transformation, how did the, I can't talk, how did this g of x, right? How is that different from the original, right? The original parabola. Now remember the original parabola is right here on 0, 0. So it looks something like this. That's not terrible. Okay, and then if you look at it, it just shifted down 4, right? And if you notice this -4 right outside here, it's related to the shifting 4 down, right? And if you want to go on Desmos, I would recommend that you try those out. It is interesting to see how those change. Well, what happens if it's a +3? What happens then? What do you think is going to happen, right? So if you notice on here, I just pulled up Desmos really quick, and this is the red is the original. So this is the parent function, right? X squared, and this is x squared -4. And notice it does shift down 4, like what we said. And if you notice right here, so if we change that, instead of going -4, +4, what do you think will happen? And look, so it's changed to +4 and it goes up 4, right? So this is kind of the transformation. This is the translation that we're talking about. So whatever's out, the number outside here, what do you think it's going to do? So if I say like, oh, plus 2.5, right? And if you notice right here, this is now here, the vertex, remember that lowest point here is called the vertex. That vertex is right here at 2.5, which is what we said it was going to be, right? So if it was like -1, right? So that's going to be right down here at -1. So that's how that's how it moves. So it has the exact same shape as this parabola right here. It's just shifted down. So if we look back on here, okay, so that's the shift. And then if we look at B, is we're going to find the inverse as well as the sketch the graph, right? So in order to find the inverse, do you remember what we need to do? So we're going to take the x and the y, and we're going to flip them, right? So instead of g of x, we're going to write down y. So technically, we could have written down right here, y is equal to x squared -4. That would be like our step 0. And if you look back, I think on page 20, it does give you the steps on how to write the inverse equation. And so again, once you write down and replace the g of x right here for y, and now we're going to flip the x and y, right? So we have x is equal to y squared -4. And then we're going to just solve for y. So again, add 4 to both sides. And once you write that down, then you have to square root it, right? That's how you get rid of the square. So we're going to square root both sides, and you're going to get y is equal to plus or minus the square root of x plus 4. Note that you need to also put in the plus or minus, and make sure that your square root is all the way over the 4 as well, because the 4 was there when you were square rooting. So it also needs to be under the square root. So we're going to graph it. And remember, if you remember like last time, or even right now as we're doing this equation, right, what did we do? We literally just flipped the x and the y, right? So on our table, we're going to flip the x and the y. So this is going to be our inverse. So I'm going to write the inverse here like this. So the inverse xy, so instead of being -3, 5, we're going to write down 5, -3. And then we would go here, right 5, and then up 3. So do you see that pink point? That would be that point. Same thing here, instead of being -2, 0, it is the inverse, so 0, -2. And you would do that for all of these, and you would end up getting these points right here. If you did not do that in class, or you were not in class, I would do those. Okay, pause and go do it. Now you should have a parabola that is like, actually for you guys, it would be this way. That looks like this. And it does open right. Let's see here. Is it a function? No, it does not pass the vertical line test, right? And if you remember the vertical line test, it's if it hits the point at if it hits the line at any 2 points, then it's not a function. Even once, it's not. But if you see here, right, we could draw a vertical line here and it would be like, oh yeah, passes twice every, like so many times, right? The only time that doesn't happen is right here at the vertex. But yeah, all of these times it hits it like 1, 2, one down here and one up there, right? So the question is, how can we make it into a function, right? So what can we do? So that's what today's about, is these domain restrictions. We'll get there. So if you notice right here, let me bring this back. Just copy this guy, bring it right up here. Okay, so if we're doing the domain and range of both the function and its inverse. So in black, that is going to be, so the domain is, if it's pointing a little bit to the left and a little bit to the right, it could be all real numbers. And if you look at the function, right, if you look at the function x squared, what number can we put in for x? Anything, it doesn't matter. We can put any number in there and we can square it and then subtract 4 from it, right? So that's how you know it's all real numbers. There are no restrictions on this. Okay, so from -infinity to +infinity. Same thing with the range, that's talking about the y. So how low does this go? So if you look at that graph, it goes down to, and don't say 4, because 4 is how much it's shifted left and right. We want to know how low it is, right? So on the y, it's 0. That's as low as it's going to go, right? So since it can't, so is that the same one? That's not the same one. Arc. Okay, I'm going to just erase it. I'm like, that doesn't look the right. Okay, so we're going to look right here. I'm going to just snip this because apparently it didn't get snipped. 1 second. So now I've snipped it. Okay, so now how low does this go? Yes, it goes down to -4, right? That's what we're looking at right here. So -4, and anything from -4 on up. And notice it can be -4. That's where we have the square bracket like this. All right, and then that's going to be 2, yeah, because it goes up to infinity. And if you notice that the domain is going to be, so the domain of the pink, the inverse, right? That's going to be, it goes as far left as -4. It does not go any further than that. There's no more graph after that, right? This goes from -4 to infinity. And then the range, it goes down and up, both of them. So it's going to be from -infinity to +infinity. And if you notice, like people noticed before, the domain for the function is the same thing as a range for the inverse, which makes sense because remember what we did, we just flipped the x and the y's. So the domain and range should flip. It should be the same, but flipped. All right. If you want to look at this algebraically, if you take a look inside here, if you look inside the square root, right? And there is a restriction here because square roots can't actually be negative. The inside, right? Not the outside, the inside. So inside here, the lowest number it could be is 0. So if we put in this -4 in here, so -4 plus 4 is what? 0, right? So the square root of 0, and that's as low as we're going to go. So we cannot, because if x was, let's say, let me use this. So if x was -5, let's just pretend, plus 4, and what would happen? Well, this would just be -1, because -5 plus 4 is -1. What's the square root of -1? I. Not graphable. We can't graph I on this kind of table, right? On this kind of coordinate plane. So yeah, it can't be negative. So that's why we would not be able to, so x cannot be -5. That's why. Algebraically, that's why, right? Graphically, we can see, like it literally doesn't go to -5. You know why? It's imaginary. It's not there. All right, so that is the algebra-ness of that. And we're going on to the next one right here. Isn't that the same thing? Oh, these are the restrictions. I don't know why I was so confused before. Anyways, I was just confused. You must have been like, Miss Lee, that's fine. I don't know. Anyways, or maybe it wasn't. I don't know. So here we go. So list the domain and range for both of these. So now, okay, we're going to restrict it because we're like, we want the inverse to be a function. So we're like, okay, well, if we could get rid of this bottom part of this inverse, then we'd be fine. Then there'll be no more overlapping, right? We wouldn't have a top point and a bottom point, right? We would just have the top point. That's it, right? So, and if you remember from before, this top part right here corresponds with this other highlighted part right here. So if you remember this guy? Still here. So remember, if we were flip it, so this is what I'm pointing at. I'm pointing at the upper left, right? And if we reflect it, notice where it is that top part right here. That's what we want. And that top part, that's what we want. That is going to be this left-hand side, right-hand side. My left, your right. Okay, so this is the right arm. Okay. So which is this right arm right here. So far, so good. So now what we're going to do is, well, how do we want, okay, how do we restrict this? So we only want this right-hand side. From the vertex, we only want the right-hand side of it. How do we restrict that? So what is x equal to? So if you look at Desmos, here's our minus, let me go back to -4. I don't need that guy. So if you want only just this right-hand side right here, how do we restrict that? So x is greater than or equal to, and it's not nice if that's outside. X is greater than or equal to. There we go. And if you notice, some people would say 4. Well, let's try 4, right? Oh, where did it go? It's gone. It's not here. Oh, there it is. There it is, all the way up there, right? It's all the way over here at 412. Okay, that's not what we want. Okay, we're missing a whole bunch more of this. I mean, when we invert it, it'll be a function, but that's not the whole function we want, right? So let's try a smaller number, right? Like 3. And notice it goes down lower, right? But we want it to go all the way down to this, because that was where the vertex was, right? At the 0. Oh, why don't we just put it at 0 then? Ah, right here. So it was right here. And if you notice the x equal to 0, right? Because remember, on the vertex, which one represents your AOS? Because remember, the AOS is that line that where both sides are symmetrical, right? If you remember back in last quarter, right? So that we want it where the AOS is. So the AOS, see, it's all related. The AOS is going to help us with that domain restriction. So we don't have to calculate it because we can visually see, oh, it's just 0. Okay, but if you wanted to calculate it, you totally can, no worries. So that's going to be our domain restriction. So that's why here we have x is greater than or equal to 0, because that is where the value anywhere from x is equal to 0 on is going to give you this right-hand side right here. So far, so good. So then what does that mean for, what is it called? The inverse. So that means if we're restricting the original function, all we're going to have left is this top part right here. All right. So which is just the positive portion, not the negative portion. The negative portion would be that bottom one down here. If you don't believe me, let me show you. So if you look right here, so we have the square root of x plus 4. See? And if we do the negative of that, look very carefully, other side, right? And so we're going to go back to the top, right, like that. It's like a game. It's going around in a circle very fast. Sorry. So that's what it's going to do. Okay. So this is what we're looking at right here. So that's just this top half. And now is it a function? Yes, right? Because it only do the vertical line test. We don't have any more like 2 numbers, 2 points intersecting. It's just this 1 point on here on top. That's it. All right. So how does that change the domain? Well, now the domain has been restricted, so it's no longer all real numbers. Now it can only be from 0 to infinity, or 0 to infinity. The way you guys with 0 to infinity. And then the range is still the same because we did not change that part because the lowest part is still true. It's still at -4. So it's from -4 on up. So again, the only thing that changed was the domain, which would in turn change the range for the inverse, right? Because, you know, they're related. And again, the domain is the same. And notice right here, again, we did not put in the negative here. It's just the positive, and that's why we could write g -1 x, which is the inverse of g, because it's the function notation. All right, and this is a brief reminder for those of you guys who did not remember. Remember, the closed bracket means including, so including that number, so including 0, and the parentheses means not including. So with anything with infinities, we technically can't include that because you can never get to infinity, because if you're there, that means you're not at infinity, right? Because infinity is always beyond that. It's weird, you know. All right, so let's take a look here. So this was a different equation and a different function and a different graph. So notice right here is x -4, and notice what happened to it. It shifted to the right 4. Remember, it's like kind of like opposite of what you see. Right? Anything in parentheses, I feel like is always opposite of what you see. That was true with roots. That was true with this right here, with the moving the graph. It's also in vertex form, which is true for vertex form as well. And the parentheses is always opposite, right? So it shifts to the right 4. And if you remember, let's see here, what was I doing? Then think about, well, what if it was x +4? Then would shift to the left 4? You should try that on Desmos. See if that's true. I'll wait for you. Okay, you can just push pause. And then write the equation for the inverse. So this is how we did it. So we're gonna, okay, so notice right here again, we take the h of x, change it out with the y. Okay, so we're just using y. We're not using function notation anymore. So, and then we're switching x and y like this. So I should say, guess I technically didn't switch there. So y is equal to x -4. That's a 4 squared, right? And then we're going to switch x and y. And then once we do that, right now we have to square root first because that's on the outside. So we're going to square root both sides first to cancel out the square. So again, on the left hand side, it's going to be plus or minus square root of x is equal to y minus, that's a minus, y -4. All right, and then we're going to add 4 to both sides. And then to get rid of the -4. And so all we get left is y is equal to plus or minus square root of x plus 4. All right, and what we're going to do here, oh, I just wrote it up like this. And so we just want, well, we won't get there with the function part yet. So here it is. So this is going to be y is equal to plus or minus square root of x plus 4. And what we just did was you just take these points. So this is 4, 0. So in my brain, I'm writing a table. And so I switch those two. So this is going to be 0, 4, which is up here. I try to color coordinate them. So this is 5, 1. So this is 1, 1, 5 right up here. Right. And I did all the right hand side ones, which corresponds to this one up here. And then I just, here's a line of symmetry. If it's one above the line of symmetry, then there's got to be one below it, right? Because it's symmetrical, right? And if it's 2 above the line, then it's going to be 2 below the line. So that's how I found these other points. If you want to go and find these other points, and then so like this, for example, is 3, 1. So the opposite would be 1, 3. See that point right there? That's what that is. Okay, you can do that as well. Either way is okay. Is it a function? Yeah, it's still the same. Not a function because it does not pass the vertical line test all the day long. It's kind of like a cent sign, right? Actually, for you, it would be this way, I suppose. And we're talking about the domain and range. So again, if we take a look at this, again, for the original function, x can be all real numbers. So from negative infinity to positive. The range, the lowest it goes is down at 0. Don't look at 4, right? Because 4 is not it. We want to know how low it is, not how far right it is. So how low it is, which is going to be 0 all the way up to positive infinity. And then for the inverse, right, it's going to be the exact opposite. So how far left does it go? It goes all the way to 0, right? It doesn't go any further than that. And it goes, and it keeps on getting positive. So it's going to be from 0 to infinity for domain, and for the range, that could be anything. All right. And we're talking about restrictions again, right? What can we do to restrict it? Because we won't want just the right-hand side of that parabola. So this orange section that was highlighted. So let's try this on Desmos. I feel like that is helpful. So we're just going to modify this just a little bit. There we go. All right, so if we take a look at this, we want just the right-hand side. So if you look at right here, we have it right now set at 0. Well, obviously that doesn't work because we still have this like overlap, right? Does not pass a horizontal line test. So let's try 1. Notice, okay, we're getting closer. 2, closer. 3, up closer. 4, yeah. And where have I seen that number before? 4, where is that from? Remember, that's our, again, our axis of symmetry, right? Which is also the X part of the vertex. They're all related, right? And so that's exactly what we do. And that's why we said X is greater than or equal to 4. That's what it has to be. And if you notice right in here, yeah, that's what it's going to have to be. So how does that change our domain and range, right? Should not change our range for the regular function, right? But it should change the domain because we restricted it now. So it's going to be from 4 to infinity. There we go. And you can see that that is true here. So we go, the furthest left we can go is 4. And then we just we can go all the way to the right here. Can't go to the left from there. All right. So, and if you notice right here, we're saying, okay, well, how can we figure this out without a graph? And this is what we're trying to figure out. And so the first equation for number 5 is x squared minus 2. We're going to resist the temptation to go on decimals because that makes it easy, right? So, but we can imagine in our brains, right? Well, what would the function look like? We learned about this. Remember, minus 2 means it's going to go down 2. Is that what you were thinking? So minus 2 is going to go down 2. So how does that affect the domain? It doesn't. Well, so how do we restrict it, right? So remember, that's going to be where x is equal to 0, right? So x has to be greater than or equal to 0 because remember, we did not shift left or right. We just went down 2, right? So the AOS is still there on the y-axis, okay? So that's what we said, y is greater than or equal to 0, right there. The inverse, the work for the inverse, it is over here on this right. It's an orange, if you can see that right here. And this is going to be literally, we flip the x and y's. So take a look at it, see if you got what I got, right? And then I just did when I wrote down the inverse, I just did the positive part instead of the negative one. Okay, so it's going to be positive square root of x plus 2, right? Now, how do we find the domain and range of the inverse? So if you just look at the inverse, how do we figure that out? Remember what I had mentioned earlier in the lesson today, in this video, right? I said inside the square root can only be a 0. So that's what we have right here. It can only be a 0. All right. So because anything, if it's like a negative number, we're dealing with imaginary numbers. We're not doing that. They have to be real. Okay. So how do we get this inside to be a 0, right? Because that's the smallest number it could be. So if we say that, I'll write this over here. So this is for x plus 2. So if we say that x is, remember, x is just a number. So if x is 0, we get 0 plus 2, which is square root of 2. Can we get smaller than that? Yeah, we should get smaller than that. So how small what can we do? What does this have to be right here so that it will equal square root of 0? And some people are like, well, negative 2, because negative 2 plus 2 is 0. And then, yeah, there we go. So that's why we have here that the domain is going to be, the smallest it could be is negative 2, because what happens if it's negative 3 or negative 2.1, right? Then we get into imaginary numbers. We can't have that. So the inverse, so the domain is going to be negative 2 all the way positive, because x could be a really big positive number, like a million plus 2 square root, we can still get an answer, right? Because it's positive. All right, well, what about the range? So how small can this be inside the square root? The smallest number that the whole thing can be is 0, right? Because negative 2 plus 2 is 0. Well, what's the square root of that? Square root of that is 0. So the smallest it could be is 0. So literally, I would just plug this number in to the equation and see what would y be, which happens to be 0 at this point, right? Okay, now if we really want to check, so x squared minus 2. So let's just try. So x squared, let's try it right here. X squared minus 2. And if you notice, let's put in that restriction like we said. So x is greater than or equal to 0. Yes, we got it right. So it's exactly what we said it was going to be, right? This is the right-hand side of it. We have the vertex right here at 0, negative 2. Okay. And if we want to talk about the the range. Let me just put that in here. So that's going to be square root of, what did we say, x plus 2? Right, there we go, x plus 2. And the domain, again, x, so it goes all the way to -2, like we said, and goes positive. And then how low does it go? The range goes all the way to 0 and up, right? Which is exactly what we said it's going to be. We figured it out. Okay, so for the next one, for B, if you did not do this one, try this yourself. Okay, it's good for you to struggle with it and try to figure it out. Okay, and then watch this video. All right, so we have x plus 2 then squared. So think about what that does. Remember, it's plus 2, which means instead of going to the right 2, we're going to go to the left 2. So what does that mean? We're going to be on the negative side at -2. Think about what that's going to be. Right, so that's why we wrote here, well, x can be greater than or equal to -2. I told you these are related, right? And then from there, if you notice in the pink right here, we find the inverse. So follow that through and see if you get that. If not, then look carefully. And then, so we, again, for the inverse, we're just using the positive section right here, the positive part. So positive square root of x and -2. Then what would be the domain? Okay, so if you look at the square root, because that's the thing that's going to kind of tell you, help you with this. So inside here is the x. So what is the smallest number that x can be? Here, small, because there's no other like +2 or -2 or whatever, right? It's just an x inside the square root. So it's just going to be 0, right? Because that's going to be the lowest it could be. Because if it was -1, that's now square root of -1 is I. Again, imagine, we don't want that. So it's going to be the inverse of the domain of the inverse is going to be from 0 to positive infinity. All right, well, what about the range? So like I said, plug in the 0. See if I can scroll down here really quick. So we're going to plug in the 0 in here. So we're going to get square root of 0 minus 2. So what is that going to equal? That's 0 minus 2, which is -2. So this is the lowest number that it can be because I inputted the lowest x value. So that's going to give me the lowest y value, which in this case is going to be -2. So this is going to be from -2 to infinity, right? So that's going to be the range of the inverse. And if you want to take a look at that, because you're like, man, Miss Lee, I need some proof. So we're going to go right here. So I'm going to change this to +2. Delete all that, guys. So +2, where is it? Oh, it's all the way up here. So that's why we have to, oh, was it +2? It was +2. And we said that that was going to be 0. Oh, -2, not 0. Right. We said -2. Go look at your notes. Yep, there we go. So what happens when we don't pay attention? There we go. So -2. There we go. Now we have the whole like little curvy shape right there, like that, right? So we have the right side right there, and we want to get the other one, which was, remember, square root of x minus 2. There we go. And so again, we said that the domain was going to be from 0 to infinity, which it is. And the range is going to be from -2 to positive infinity, which it is. See, happy days. That's exactly what we said. It's a good way to check. All right, I'll see you guys later. We'll talk about 2.3 at the next time we meet.